Hey, this is number 7 on 6.1. What you have here is a lottery with different prizes. There's a grand prize, a $200,000 prize, a $10,000 prize, and you're given all the probabilities of getting those prizes, including the probability of getting nothing. So this is a probability distribution, and they ask us if the grand prize is 14 million, find and interpret the expected cash prize. And then they ask us if a ticket costs $1, what is your expected profit? So the first thing is the expected cash prize. That's really like if you got a ticket for free, what could you expect as a cash prize? Now, this one you can load up in StatCrunch, but it's actually easier in either Excel or some kind of spreadsheet. I just copied it to the clipboard and then pasted it into Google Sheets. That's the one I use a lot. So here's the info. This is just this table here. I've already put in the 14 million here as the grand prize, right, that they told us in part A. So now to figure out the expected cash prize, all we do is we just want to multiply the prizes times the probability that they get that prize. This is just a weighted average. Okay. Okay. So those are all the, whoops. Yeah, and that last one should be 0, right? Okay. Now, if I add all these together, then I'm going to get the expected cash price. So I'm just going to sum all this together. So the expected cash prize is about 28 cents. Okay. Now, if we want to get the expected value, right, that incorporates, oh, sorry, they're asking us to interpret the expected cash price. On average, you will profit 28 cents per lottery ticket. Okay. That's if it's given to you. This is ignoring the fact that you've actually paid money for it. Of course, you can't win 28 cents on every lottery ticket. Oh, hold on. So I was wrong on this one. I was like, what's the difference between A and C? Yeah, it's really, really small. On average, they both say on average, you will profit 28 cents per lottery ticket. And this is you will win 28 cents per lottery ticket. It's actually C because profit incorporates the cost, right? When you're talking about profit, it's like the revenue minus the cost. What you bring in, what you sell it for, minus the cost to make it. So same thing here. You will win 28 cents per ticket, but you won't profit that. So be careful there. I almost got caught. Okay, so the expected value for a $1 lottery ticket is just the expected cash prize minus the cost of playing, right? Because you always spend $1. So this is equal to C10 minus 1. Okay, so your expected profit is minus 72 cents. I wonder if it'll take this minus here. Yep, okay. So, and that's to be expected, right? I mean, nobody would offer a lottery if, the probabilities didn't add up to be a negative expected value, because you'd just be running a lottery that gave money away, right? When companies or states run lotteries, they have to make sure they know all the probabilities of each of the cash prize to make it a winning game for them, right? So even when somebody wins the lottery still has made money because of the expected value is always negative for the player. That means it's positive for whoever's putting on the lottery. To the nearest million, how much would a grand prize be so that you can expect a profit? Assume nobody else wins so that you don't have to share the grand prize. Okay, so what this is saying is basically the moment you start to make a profit is the moment you get above 0 in your expected value. So you could actually make up a big long equation with all this, right? Like you could just sum up these and then have that added to this probability times some variable x. The nice thing about the spreadsheet is we can actually play with this a little bit. So instead of having 14 million, let me try 50 million. Okay, see, I'm still negative. Okay, I'm getting closer to zero, right? I was at negative 72 before, and now I'm only at losing 44 cents, as I'm expecting to lose 44 cents. So maybe I go up to 100 million. Okay. Ooh, I'm getting really close. Okay, at 100 million, I'm just losing 6. I'm expecting to lose 6 cents. So what about 120 million? Okay, now I'm positive 10 cents. So it's got to be between 100 and 120. Let's go back and try 110. Okay, still positive there. Good. Let's try, let's see, 105 million. Okay, so slightly negative there. So I'm going to go between 105 and 110. Let's do 107. Ooh, almost there. Let's try 108 for the grand prize. Okay, so that puts me at an expected value of 0. I wonder if that's true even if I see all the digits. Oh, it's a little bit negative. So let's see. What about 109? Okay, that's a little bit positive. So I'd say it's between 108 and 109 million. The first million that you expect to profit is 109 million. So I'm going to say, I think we put in all of the whole million here, not just 109. Let's see, I think I'm missing a 0. 1, 2, 3. 1, 2, 3. Okay, let's try that. Okay, so that's how to do this problem. Like I said, you can do that algebraically, but the nice thing about a spreadsheet is you can kind of just play with it until you zero in on it.